Let's go to 8a. The function f is defined by f of x equals 3x plus 2, 4x squared minus 1. For x, it's real numbers. X is not equal to p, x is not equal to q. Find the value of p and the value of q. Basically, this is a domain for rational functions. We will make a denominator not equal to 0 to figure out the domain. So we have x squared not equal to 1 over 4. Square root both sides. We will get x not equal to plus or minus 1 over 2. So p equals 1 over 2. Q equals negative 1 over 2. 8b, sketch the graph of y equals f of x for x is greater than equal to negative 3, less than equal to 3, showing the value of any axis intercepts, the coordinates of any local maximum and a local minimum, and given the equation of any asymptotes. We know for the vertical asymptote line is x equals plus or minus 1 over 2. Horizontal asymptote, we will do the limit as x approaches infinity of f of x, that is 3x over 4x squared equals 0. So y equals 0. For y-intercept, f of 0 equals negative 2. And for the root, we make 3x plus 2 equals 0. So x equals negative 2 over 3. Put the f of x into graphing calculator. So alpha y equals, enter, 3x plus 2 over 4x squared minus 1. Then we will change window. X minimum is negative 3. For maximum 3, scale is 1. For y minimum, negative 8. Y maximum 8. Scale is 2. After we finish setting up this window, we go to graph, local maximum value, second trace, go to 4. We know this is negative 1 over 2. For the left bound, we set up negative 0.4. Enter. Then move the arrow to the right side of the local maximum point. Then enter. Enter. We will get maximum value. It's negative 0.226 and a negative 1.66. We also need to check what's going on this part. So we need to change the window. For x, we don't have to change. We need to change this y minimum, negative 0.5. Y maximum, 0.5. For scale, let's turn it into 1. Graph. There is a minimum value over here. So we need to figure this out. Second trace, go to 3. This is a negative 1, negative 2. Let's make negative 2 as a left bound. Then move. Then enter. Enter. We get local minimum, negative 1.11, negative 0.339. After we figure out the local maximum and the local minimum, we will sketch the graph. First of all, sketch the vertical asymptote line, x equals negative 1 over 2 and x equals 1 over 2. For the x-intercept, negative 2 over 3, estimate over here. For y-intercept, negative 2. And the local maximum, negative 0.226, negative 1.66, estimate over here. And the local minimum, negative 1.11 and negative 0.339. Let's estimate over here. Then we can sketch the graph. Since we need to sketch the graph for x greater than or equal to negative 3, less than or equal to 3, you have to make your graph for ending at x equal to 3 and x equal to negative 3. Then you need to label. Let's go to 8c. The function g is defined by g of x equals 4x squared minus 1 over 3x plus 2. For x is all real numbers. X is not equal to negative 2 over 3. Find the equation of all the asymptotes on the graph of y equals g of x. There is a vertical asymptote line. That is 3x plus 2 equals 0. X equals negative 2 over 3. Since the numerator degree is 2 and denominator the degree is 1, there will be oblique asymptote line. 3x plus 2 is a linear factor. We want to use a synthetic division. 3x plus 2. We will change into 3 times x plus 2 over 3. And the root is negative 2 over 3. Root in the corner. No missing power, so we have 4, 0, negative 1. Drop down 4. 4 times negative 2 over 3 is negative 8 over 3. Adding negative 8 over 3. Then don't forget divided by this 3. So divided by 3. So we get y equals 4 over 3x minus 8 over 9. Oblique asymptotes, y equals 4 over 3x minus 8 over 9. For 8d, by considering the graph of y equals g of x minus f of x, or otherwise, solve f of x less than g of x. We want to solve f of x less than g of x. Change into f of x minus g of x less than 0. F of x is 3x plus 2. over 4x squared minus 1, then minus 4x squared minus 1 over 3x plus 2 less than 0. For this complicated rational inequality, we need to draw a sign diagram. We can figure out a vertical asymptote line. X equals 1 over 2, negative 1 over 2, and a negative 2 over 3. Let's label negative 2 over 3, negative 1 over 2, positive 1 over 2. Then you need to go to graphing calculator to figure out all roots. After we put f of x minus g of x into y1, we graph in the standard window. You could say in this graph, we cannot see vertical asymptote line clearly. We only see one root here. Since we are looking for all roots, we need to change the window. This is a 2. Let's go here. This is a negative 3. So we can change the window for x-axis from negative 3 to 2. Then we need to change the window for y-axis so that we can find all roots. So change window, negative 3, 2. Let's do negative 5 and 5. Graph. So we have the second 0. Let's figure out these two roots. Second trace, 2. We know this is 1, so left bound 1. Move the arrow, then we get 1.32. And let's try to figure out this root. We know there is a vertical asymptote line, negative 1 over 2, and another vertical asymptote line is negative 2 over 3. So press trace first. Let's do negative 0.6. This will be the left bound. So second trace, 2, left bound. Then you move the arrow to the right bound, enter, enter. We will get negative 0.569. Let's go to this sign diagram. We have 3 vertical asymptote line. And we already got 1.32 is a root. And negative 0.569 is the second root. Then according to the graph, we can figure out the sign for each interval. This is a negative, positive, negative. Then between this is a positive, negative, then positive. Because there is a vertical asymptote line, this is negative 2 over 3. And another one. So here is negative 1 over 2. Then we have the third vertical asymptote line is 1 over 2. Then use this sign diagram, we can write down the solution. Since we are looking for less than 0, which means below x-axis or the interval with a negative sign like this, and this will be the solution. So the final answer will be x greater than 1.32 or x greater than negative 1/2 less than 1/2 or x greater than negative 2/3 less than negative 0.569.